Welcome to the Explainer. So, picture this. You're sitting on a plane, cruising at 35,000 feet. Outside, the air is literally freezing cold. But inside, you're totally comfortable and safe.
But have you ever actually stopped to wonder why every single airplane window, that little window right next to you, is perfectly round? I mean, it might just seem like a simple aesthetic choice, right? Or maybe just the way things have always been done.
Well, the truth is, those rounded windows only exist because engineers learned a really deadly lesson the hard way. A lesson that fundamentally changed aviation forever. Because believe it or not, early passenger jets actually had square windows. And that one tiny design detail, it led to a series of disasters that absolutely shocked the world. Which brings us to part one, the age of the first jet airliners. Let's travel back to the 1950s. A British aircraft called the de Havilland Comet had just become the world's first commercial jet airliner. And it was incredible. It flew higher, faster, and way quieter than anything before it. Passengers absolutely loved it. Airlines were rushing to buy it. Honestly, everything seemed perfect. But then something terrifying started happening. In May of 1953, a comet disintegrated right after takeoff from Calcutta. Then another one mysteriously crashed off the coast of Elba. And just 3 months later, a third crashed near Naples. These beautiful aircraft were suddenly breaking apart in midair, completely without warning. Investigators were totally baffled. How on earth could such a modern, advanced aircraft fail so catastrophically? So to figure out what was going on, investigators did something really fascinating. They built a gigantic water tank, placed a stripped-down comet fuselage right inside, and repeatedly pressurized it with water 24 hours a day. They were basically simulating entire flights in just a matter of minutes. In less than a month into this test, the fuselage catastrophically tore open, and it finally revealed the fatal flaw. That takes us right into part two, the hidden problem. You see, engineers eventually discovered the root of the problem. The aircraft's windows were square. Now, at first, that doesn't sound dangerous at all, right? But when an airplane flies at high altitude, the cabin has to be pressurized. Inside the aircraft, the air pressure is much higher than it is outside, and this creates enormous stress on the aircraft's structure. Here's the thing about stress. It behaves in a very specific way. When force reaches a sharp corner, it gathers and concentrates right in that area. Engineers actually call this stress concentration. Because of this, the corners of those square windows became massive structural weak points. In fact, an astonishing 70% of the fatigue stress on the Comet's entire fuselage was being focused directly into those sharp, square corners. And because of all that extreme stress, microscopic cracks were forming at those corners during every single flight. At first, they were totally invisible to the naked eye. But, after hundreds of flights, they kept going larger and larger, until eventually the metal just couldn't handle the pressure anymore, resulting in complete, catastrophic structural failure. Okay, part three, why round windows solve the problem. So the solution here was surprisingly simple. Just remove the corners. As we just saw, stress ruthlessly attacks the sharp corners of a square window, gathering dangerously in one spot. But a circular or a rounded shape, it distributes that pressure safely and evenly across the entire frame. Instead of the stress gathering up in one weak location, it just spreads out smoothly along the curved edges. A great way to think about it is like bending a piece of paper. If you make a sharp fold, you create a weak point that easily tears, right? But a smooth curve safely spreads the force out. The exact same principle applies to these massive aircraft structures. By switching to rounded windows, engineers completely eliminated one of the biggest structural weaknesses in early jets. So yeah, it's really not about appearance. It is literally about survival. Let's move on to part four, the engineering behind modern windows. Today, modern airplane windows are incredibly robust, way stronger than they might look. They're actually built like a really clever 3-ply layer cake. You have the tough outer pane, which is the thickest structural layer. That one handles all the extreme external atmospheric pressure. Then there's the middle pane, which acts as a structural failsafe. And finally, the inner pane, the one you can actually touch from your seat. That one doesn't hold pressure at all. It just protects the middle and outer panes from passenger scratches and normal wear and tear. And even the tiniest details in these windows serve a massive purpose. Like, have you ever noticed that tiny little hole at the bottom of the window pane? That's called the bleed hole. It's an absolute multitasker. It regulates and equalizes the cabin pressure between the window layers, it prevents condensation and fog from blocking your view, and it ensures structural redundancy just in case the inner pane accidentally cracks.
Now, the materials matter just as much as the shape. Passenger cabin windows are typically made out of super clear, lightweight acrylic. But up in the cockpit, those windshields use polycarbonate, which has massive impact strength and maximum energy absorption. They're specifically engineered to survive extreme events like high-speed bird strikes. Which brings us to part 5, the surprising lesson. What's truly fascinating about all of this is that one of aviation's biggest safety improvements came from something that seems so incredibly ordinary, a simple shape. As author Dee Dempster powerfully wrote back in 1959, no aircraft has contributed more to safety in the jet age than the Comet. The lessons it taught the world of aeronautics live in every jet airliner flying today. Those heartbreaking losses didn't just end in tragedy. They became the direct catalyst for the incredible, life-saving innovation of modern air travel.
So the next time you're on a flight, just take a moment to look at the window beside you. Those perfectly rounded corners aren't there for style. They're there because engineers learned exactly what happens when they aren't. Will you see the beautiful, life-saving engineering history written in your round window on your next trip? I sure hope so. Thanks for joining me on this explainer, and as always, stay curious.